Alright, so we're talking about Pythagorean Theorem now, and your learning target is I can use the Pythagorean Theorem and its converse to solve problems. So the first question we need to answer here is, what is the Pythagorean Theorem? And a lot of you guys will probably already know what Pythagorean Theorem is, but Pythagorean Theorem is a squared plus b squared equals c squared. Okay, that deals with right triangles. Pythagorean Theorem deals with right triangles, where a and b are the legs of the triangles, and c is the hypotenuse. And essentially what it means here is that when you square a and you add that to the square of b, that is going to equal the square of c. Okay, and so let's go, there's also a converse of this, and the converse just pretty much means the opposite of the Pythagorean Theorem. And what that says is that if the sum of the squares of the lengths of two sides of a triangle is equal to the square of the length of the third side, then the triangle is a right triangle. All that's saying here is that if this squared is equal to the sum, the addition of a and b squared, then we have a right triangle. Okay, it's just pretty much the opposite of what Pythagorean Theorem says. The key concept here to understand when we're solving problems with Pythagorean Theorem is that the first thing we want to do is substitute the given values that we know in for a, b, and c, and then solve for the missing variable. Whatever we're missing, that's what we end up solving for. So example 1 is asking us to find the value of x, and we're supposed to give our answer in simplest radical form if we need to. So first let's write down what the Pythagorean Theorem is. Again, it's a squared plus b squared equals c squared. And remember, a and b are those two legs of the right triangle. So this could be a, and then this could be b, which means that the hypotenuse right here, the length opposite the right angle, would have to be c. Okay, so let's go ahead and plug those numbers in. We're going to substitute them. 5 in for a, so we have 5 squared, plus b is x minus 1 squared, is going to equal our c, which is just x squared. Okay, and our job then is to find what is the value of x. So let's go ahead and solve this here. We've got 5 squared, which is just 25, plus x minus 1 squared. When you reach this type of a thing, sometimes it's easier to break those into 2 and then multiply them. So we're going to go x minus 1 times x minus 1. Okay, that's the same thing as x minus 1 squared. We just split it into the 2. Okay, and set that equal to x squared. Okay, now it's easier to multiply these. Remember, we have to FOIL it, do the first, the outsides, the insides, and then the last. So we're going to do that now. We've got 25 plus x times x is just x squared. X times negative 1x, or is negative 1x. Negative 1 times x is again another negative 1x. And finally, negative 1 times negative 1 is a positive 1. Okay, now we can get our common terms, our like terms. We can combine those, and so we've got all of our x squared is our largest one. So let's keep x squared at the beginning. Combine the negative 1x and the negative 1x to make a negative 2x, and 25 and 1 add up to be 26. Set that equal to x squared again. Okay, and now we just have to solve for x. So we're going to subtract x squared from both sides. We end up getting a negative 2x plus 26 is equal to 0, because x squared minus x squared is 0. Subtract 26 from both sides. We get negative 2x equals negative 26. Divide by negative 2. And we're going to end up seeing that our answer is x equals 13. X equals 13. Okay, example 2 says to again find the value of x and give your answer in simplest radical form. So let's do the same thing here. We've got a squared plus b squared equals our c squared. And we're going to plug in, we know the legs are a and b, and then our hypotenuse, the length across opposite of the right angle, is our hypotenuse C. So let's go ahead and plug those in. We've got 6 squared plus 2 squared is going to equal x squared. And now it's just solving, right? 6 squared is 36 plus 2 squared, which is 4, is equal to x squared. We combine the like terms to get 40 is equal to x squared. We want to get x alone. Remember, that's our job, so we're going to find the square root of x because that'll cancel out that square. And we'll be left with x is equal to the square root of 40. Now remember, our job, though, it says, is to give our answer in simplest radical form, which goes back to our first lesson, right? We've got to try to figure out how to write this. We've got to free some of those people or some of those numbers from jail here. And we can see, let's try to think of what maybe some of our easiest numbers would be. We know that 4 goes into 40. We could use 4. Is there any of those other numbers? Let's think about those other squares. 9 doesn't. 16 won't. And our next one after that is 25. And 25 doubled, we know, is 50. So let's stop there. We know that what we're going to split this into is the square root of 4. 4 goes in 10 times. Times the square root of 10 is equal to x. And now we can simplify this because the square root of 4 is 2. We freed the square root of 4. It was a good perfect square, so we got rid of it, and we finally came up with our answer, our perfect answer, as 2 times the square root of 10. Real quick, we're going to mention something about Pythagorean triples, and what those are is those are a set of 3 whole numbers. So your A, your B, and your C, when we're talking about Pythagorean theorem, those are all 3 going to be whole numbers. And so let's talk about a few common sets real quick. A lot of the times we see the 3, 4, 5 Pythagorean theorem, or Pythagorean triple. 3 squared plus 4 squared is equal to 5 squared, is what that means. Another one of these is the 5, 12, 13. The 8, 5, 17, or sorry, 8, 15, 17. And I'll throw one more at you real quick, the 7, 24, 25. All those mean is we've got whole numbers. These are the common ones where in order as A, B, and C, we've got 5 squared plus 12 squared is going to give you 13 squared. 8 squared plus 15 squared is going to equal 17 squared. Those are just our simple Pythagorean triples, the whole numbers that will work for Pythagorean theorem. So for example 3, we want to find that missing side length, and then we could be able to tell, is this truly the side lengths, is this a Pythagorean triple, and then explain it. Okay, so what we know here is we've got our A, we've got our C, but we're missing our B. We don't know what B is. And so let's go ahead and remind ourselves of what Pythagorean theorem is. It's A squared plus B squared is equal to C squared. And let's go ahead and substitute now all of those values in for what we know. We know A is 4 squared, plus B squared is what we don't know, is equal to C squared, which is 12 squared. Okay? And real quickly, we can already tell this is probably not going to be one of those Pythagorean triples because I gave you some of the lower number common sets, and we don't have a 4, 12, or 4 something 12, right? This would have to be 3 and that would have to be 5, but nowhere else do we see a 4. But let's go ahead and solve this still. We've got 4 squared is 16 plus B squared is equal to 144. Subtract 16 from both sides. And we're left with B squared is equal to, man, what is that? That's going to be 128. Find the square root of both, and we get B squared is equal to just the square root of 128. Now we can do as our freedom perfect squares to try and free some of this out. See if we can get a perfect triple. Sorry, we got rid of that square. And we see that 64 goes into 128 and it goes in twice. So we've got B is equal to the square root of 64 times the square root of 2. But that doesn't do us too much good because we're going to be left with B is equal to 8 times the square root of 2. So that missing side length, this is the important part. The missing side length is 8 times the square root of 2. We needed that piece of information, so that's part of our answer. But the second part of our answer is tell if the lengths form a Pythagorean triple. We can say no. And the reason why is because 8 times the square root of 2 does not equal a positive number. It's not equal... Sorry, no, it does equal a positive number. It does not equal a whole number. Alright, that's it. Hope you enjoyed.